Imagine having an idea that you can't physically realize. Frustrating, isn't it? One of the most important parts of the design process is being able to fully convey a design or engineering idea and then make the right choice for your production. Choose from more than 120 different materials, ranging from opaque shades to full transparency and from rubber-like flexibility to ABS-grade engineering plastic performance. You can even print different material properties in the same model at the same time to achieve the true look and feel of your final product. The Object 1000. Big models, flawless precision, no compromise.
Additive manufacturing is a process enabling the production of solid objects in any shape and form, starting from a digital model through a process of aggregating materials, in this case metallic powders. An example of the great freedom in designing shapes and forms is the combustor injectors. This part, if made by casting, is produced with 5 pieces, which must then be joined together. With additive manufacturing technology, only 1 piece is produced. Among the raw materials used by Avio Aero for additive manufacturing is TL, titanium aluminide, an intermetallic material formed from titanium and aluminium. In the production that harnesses additive manufacturing, these materials are used in powder form. This allows the production of components with a particular performance, like, for example, airfoils for low-pressure turbines, designed for the hot parts of the engine where temperatures reach up to 740 degrees centigrade. The use of TL enables a reduction of about 50% in the weight of components, which means lower fuel consumption and therefore lower emissions. Products are uniform. Additive manufacturing guarantees metallurgical uniformity of the product. Mechanical characteristics are better. Pieces are more resistant. It is a technology that reduces emissions to the minimum. Manufacturing is carried out in vacuum chambers with no harmful exhaust emissions. Moreover, to make a product weighing 1 kilogram through casting, about 4 kilograms of material is needed, while only a maximum of 1.5 kilograms is used with the additive manufacturing technology. Less material, less energy, less emissions. Production times are greatly reduced, no longer months, but just a few days to produce the same amount of product at a speed of 50 cubic centimeters an hour.
We start with a 3-dimensional computer-generated model, which we then slice into a series of very fine layers, a little bit like a loaf of bread. We then reassemble those layers by spreading a metal powder, in this case titanium, across the build table, and then use a laser beam to fuse the layers together on top of one another, creating a 3-dimensional part. Well, we can create very intricate shapes with this process. The material strength is the same as the standard dropout material. On top of that, we have the ability to make multiple parts in one build run, each of those can be slightly different.
So when this is finished, we're going to take it out. What exactly do we do?
Well, we remove them from the plate, the parts are sent away for polishing and then ready to be assembled onto the frame.
A prosthetic leg is a brilliant utilitarian technological device, but it's not something that you really get excited to see. You're not intrigued by it. You're not fascinated by the beauty of it and the personality and that unique style that connects it to the final user. Fairing, and that is a name that we borrow from the motorcycle world. It's the thing that wraps the engine and gives it its shape. In our case, it wraps the hardware of a prosthetic leg and it gives the person their symmetry back, it gives them shape, it gives the prosthetic leg some personality, some uniqueness.
The 3Doodler, the world's first 3D printing pen.
I've got to say, the guys in later, it would have been like, I'm not an artist, I'm an artist, is it? Something like the sun and huge,
NBA.
you.